welcome to our first lab of the semester. For this lab, we're actually going to be doing a series of smaller labs back to back. We're going to start with the first of our smaller labs, Lab 1.1, the hand warmer. If you're following along with this lab at home, you only need one thing, a thermometer. If you're going to follow along at home, pause the video now and grab your thermometer. We're going to start by, this is a digital, so I'm going to turn it on. I'm going to make sure it's reading in Fahrenheit. And we're going to start by just holding it in between our hands for a full minute. Go ahead, I'll wait, and we'll come back here in 60 seconds to see what temperature it reads. A minute has passed, and I'm looking at my thermometer. It reads 93.8 degrees. At this point, if you're following along on the video, record that the initial temperature was 93.8 degrees. If you're doing this lab at home, put the temperature that you got on your thermometer. The second step of this lab is we're now going to rub the thermometer in between our hands for another full minute. You can count to 60, or if you're using a digital thermometer at home, it might beep when a new temperature has been recorded. Go ahead, rub it in between your hands, and we'll check back here in 1 minute. Okay, a full minute has passed, and I'm looking at my thermometer now. It says that the temperature after rubbing my hands together for a minute is 95.2. Now, that's a different temperature than we recorded initially. Make sure that you record this as our final temperature after rubbing our hands together. If you're doing this lab at home on your own, of course, record the temperature that you got. For the final part of this first lab, I noticed that the temperature in my own classroom hasn't changed. So, I want you to tell me what you think about what caused this temperature to change. What physically happened in order for the temperature to change? And while you're at it, go ahead and tell me, do you know of any other ways to change the temperature of something? This is the second part of our first lab, 1.2, constructing a graph. If you're doing this lab along with me at home, you'll need three things. A ball of some kind, like this tennis ball, something to measure time with, you could use your phone or a stopwatch, and something to measure distance with, like a ruler or a tape measure. Now, the idea for this one is that we are going to roll the ball across a flat surface, and we're going to measure how far it can get in certain amounts of time. So, for example, I could set up my meter stick here on the table, and when I start rolling the tennis ball across the table, I'll press start on my stopwatch. At 5 seconds, I'll press stop on my stopwatch and measure exactly how far the tennis ball has rolled in 5 seconds. So, start and stop. Now, I'm actually going to collect my data off camera for this one because I want to have a bit more space than my table. I'm going to go out into the hallway and roll it. All right, welcome back. If you did this lab at home, go ahead and fill in a table with your own measurements. If you're just watching this along with me, let's take a look at our results. After 5 seconds, my tennis ball had rolled 15 meters. When I waited 10 seconds, it rolled further, it rolled 25 meters. And then when we waited 15 seconds, the longest amount of time, it rolled even further, 30 meters. Whether you did this lab with me or at home, make sure you have this table filled in, because the next part of this lab is all up to you. You are going to plot 3 points on a graph with time as your x-axis and distance as your y-axis. Once you've plotted your 3 points, connect them with a line, and then tell me, what kind of line does it look like? Is it going up with a positive slope, or does it have a negative slope? Is it straight or curved? Finally, what does that line tell you about how the tennis ball rolled down the hallway? This is the third part of our lab, 1.3, rolling around. If you're doing this lab at home, you need two things. You need another ball. In this case, I'm using a marble, but you can also use the tennis ball you used in 1.2 or any other ball that you used in 1.2. You also need something round that's hollow on the inside that you can spin the ball around with. I'm using this roll of tape. If you're using a larger ball like a tennis ball, you could use a bowl. Anything that can make the ball spin around inside. Now, there are going to be two parts to this lab. We're first going to start by making the ball roll like I've said. But once we've got it going and it's moving pretty fast, we're actually going to lift the tape or the bowl or whatever you're using. I'm going to ask you questions before and after we've removed the tape. So feel free to pause the video to answer these questions as we go. While the ball was rolling around inside of the tape, what was causing the ball to move? While you're answering that question, I want you to go ahead and predict what will happen when I remove the tape while the ball is still spinning. Will the ball continue to spin? Will it stop? Will it do something else? Write it down. Now let's test it. I'm going to make sure it gets spinning pretty fast, and then I'm going to lift it straight off. What did you see happen to the ball after I lifted the tape off? Did it stop moving? Did it stop spinning? Did it move in a slightly different way? What caused the ball to move in this way? After I removed the tape or the bowl or whatever, what forces were acting on this situation? All right, the next part of our lab is 1.4, the puck launcher. In order to do this lab at home, you really only need a couple of things. You definitely need a rubber band, something to stretch the rubber band around. I've got just 2 screws taped to the edge of my table. You could use a couple of pencils or even your fingers. And you need something to shoot with the rubber band. For this lab, we're going to shoot this puck or a piece of folded up paper or whatever you have different distances by pulling the rubber band back different amounts. For the first part, you're going to stretch the rubber band back just a little bit, maybe a couple of centimeters, and let go. Describe what happened to the puck or whatever object you have. How far did it go? Did it move in a specific direction? Did it move in more than one direction? Once you've recorded that result, I want you to pull back the rubber band twice as far. So if you pulled it back 2 centimeters, pull it back 4 centimeters. And again, let go. This time, what happened to the motion? Again, how far did it go? Did it move in one direction or multiple directions? Did it do anything special? If you're watching this lab, the puck in this time shot off the table and it did a flip, whereas last time it just kind of slid across the table. Answer these questions. How was the motion of the puck the same both times we shot it? And how was it different the second time? What force acted on the puck or other object to make it move? And finally, how did that force relate to its motion? This is lab 1.5, down the ramp. If you're doing this lab at home, you need something that rolls, so you can use your tennis ball from before. I've got a little toy car. You could even use like a little Tonka car. You need a ramp of some kind. I have a piece of cardboard propped up by some textbooks. In this lab, we're going to take our rolling object, our car, and we're going to put it on the ramp and let it go. We're going to do this from several different positions on the ramp. We're going to do it from the top, the middle, and the bottom. Do you think where we release the car on the ramp will make a difference at all? Go ahead and predict what that difference will be, or if you think there won't be a difference at all. All right, we're gonna start by releasing the car from the very top of the ramp. Go ahead and describe anything you can about how that car rolled from the top of the ramp to the end of my table. If you did this lab on your own at home, describe what you saw and observed with your own materials. Now we're going to roll it from the middle of the ramp. Again, take a moment and describe what the car did when we released it from the middle of the ramp. Specifically, was there anything different between when we released it from the top and the middle? Finally, the bottom. Okay, we've now released the car from 3 different positions and made 3 different observations. Before you move on to the next part of this lab, explain to me why. Why did the car move differently? Okay, welcome to the last of our mini labs, 1.6, the suspended bar. This lab does use some materials that are not as common around your house. For this, you will need 2 bar magnets, that's long magnets that have the opposite ends on each side, and a compass. Unfortunately, the compass in your phone, if you have like an iPhone or an Android, will not work. You need a physical compass. It's okay if you don't have these materials and just want to watch. One of the bar magnets, I've got kind of rigged up here. It really just needs to be suspended, that means hanging, in a way where it can swing freely. You can see how it's just kind of spinning around. I've got it tied up on some string to some lab equipment. So it just needs to be freely hanging. The other magnet is going to be in your hand. We are going to bring the magnet in our hand close to the suspended magnet and make some observations about what will happen. Now, just so you know, the way I'm holding it, it's labeled that the north end is what is sticking out here. So I'm going to bring my magnet close to this one and see what happens. So before it was just kind of spinning around randomly, but as soon as I brought it close, it started spinning a bit faster and it started spinning in a different direction. When I brought it even closer, you can see that it got stuck here. What will happen if I turn this magnet around in my hand? Go ahead and make your prediction. As I brought it closer and closer, it kind of slowed down. I tried to touch it and it's not sticking anymore. It's moving away. It's being pushed. Now, if you do have a compass and a magnet, go ahead and take the magnet in your hand and bring it close to the compass. How is it behaving when you bring it close? Can you make it spin? Can you make it change directions? How is it similar and how is it different from the suspended bar magnet? If you don't have these materials at home, hold on just a moment and I'll bring the camera in closer so that you can make your own observations.
All right, here we are directly over my lab table. Sorry, it's a little bit dirty. Currently, the compass is pointing straight north. Yes, that is north, I had to check. Let's see what happens when I bring my magnet close. What happened when I brought the bar magnet close to the compass? Let's see what happens if I use it like a wand, just like I did earlier. Here I have the north end, and it looks like the silver side of this compass is just kind of following it around wherever I want it to. If I bring the south end close, oh, that's interesting. Now the red end is following it around. Again, my question for you here is, what kind of force is causing the compass or that other magnet to behave this way? And why does this magnet not need to touch the compass in order to make it move?